Hey Mr. Cooper, this is my video that I'm doing for the 2006 FRQ. I just did it, I just already solved it out because it gave me a better idea of how I needed to do it. So I'm just going to explain how I did it. So that's what the free body diagram is supposed to look like for as the what is it? The force normal is going up, force gravity going down, force friction going over to the left, because the block is moving to the right and friction always opposes motion, so it's going to be moving to the right. Friction, at least. Force normal is going to be going up for the slab. This is the slab's free body diagram, by the way. Force normal is going to be going up. Force friction is going to be going this way, as the block is going, or as the slab is going to be trying to going this way, because the the block is moving this way, so it's trying to accelerate this way, but because of that it's pushing it the other direction, and because of that, as friction always opposes motion, friction is going to be going in the direction of the block, which is to the right. And then force gravity of the slab obviously going down, and then we have the force gravity of the block also going down. I got confused for a minute because I thought this was going to be a force normal, as they're both in contact, and since force normal is a contact force, but it's not that, because the force gravity is needed to figure out the calculations down here. And so when I did that, I got the right answer. So I switched the force normal out for force gravity. And basically, how you solve this problem is you set up you actually set up four different equations. Two for the x and y components for the force, for the free body diagram for the block, and then two equations of Newton's second law for the slab, right? So in the x direction, force friction is going to be going to the left. So I'll just set that up right there. Force, as it moves to the right, the slab, or sorry, the force, the second law of motion for the block is going to be in the y direction, at least, is going to be equal to 0. Mass is going to, or acceleration is going to be 0. And when you just cancel it out, you get, or you move the mg over, because acceleration is going to be 0. You get 0.5 times 10, which is 5 newtons, equals force normal. And then you just solve that out with the mu that's given, which is 0.2, and you just get 1 newton for force friction. And then you use that to solve for acceleration, and you just divide by 0.5, as you just move this equation down here. 0.5 times acceleration is equal to force friction, negative force friction. And you just divide the 0.5, and you get acceleration equals negative 2 meters per second squared. All right, so we have two variables right here for our block. Now it's time to figure out the two variables for the slab. So just similarly set up two different equations for the x and y components, and then you solve it out similarly as is with the block. So you get 8 newtons for force friction. Just apply the same method that you did up here, down here, and then you get 8 newtons equals force friction right here, and you get force, then you just plug that in, figure out force normal, and then you get, you plug in the two gravities right here in the y direction, and you get force normal is equal to 40. That 40 times the 0.2, which is mu, it gives you 8 newtons for force friction. Plug that 8 newtons over here. That should be an 8. Scratch that out. And then 3, divide the 8 by 3, and you get 2.67 meters per second squared. And then you create the two equations, the two kinematic equations. So you do the velocity final for the slab and the velocity final for the block, and as they are the same when they approach that when they approach, they both approach the same whatchamacallit, velocity at the same time, you could just set those two equal to each other, as the time is going to be the same. So basically, it's going to look like this: v naught of the block plus acceleration times time of the block is equal to v naught of the slab plus acceleration times time of the slab. And then you just solve it out, plugging in 4 for the v naught, -2 for the acceleration. That cancels out, as 0 is the velocity initial for the slab. And then you just solve it out, solve for t, you get 0.86 seconds for time. And then you finally just plug that into one of the equations, and you get velocity final equals 2 meters per second. All right. And then part C, that was part B. That was all part B, by the way. Part A was up here. And then part C, as you can see, you just plug it in to one of the equations. You put 1.2, or what am I saying? 1/2 times acceleration times time squared plus v naught t. Just get rid of that because you don't need it. So you just scratch that out. It doesn't matter which one you use because they both travel the same distance anyway. So it doesn't matter which variables, like for example, it doesn't matter which numbers you use to plug in. Like you could have used 4 over here and then like 2 right there for the block, representing the block. So then you just plug those in, one half, which is 1/2, 5, which is acceleration, and then time, which is 1.33 seconds. Square that all, and then you get 4.42 meters. That is how you do part C, and yeah.